So this question is related to preparation of chloro alkane from alcohol. An experiment to prepare a sample of 2-chloro-2-methyl propane uses a reaction of 2-methyl propanol with concentrated hydrochloric acid. So alcohol is converted into halogen alkane, and the steps how it is done are also listed. So the steps of the experimental procedure are as follows. The first thing what we did, we placed zero point 0.2 mole of 2-methyl propanol and 70 cm³ of concentrated hydrochloric acid in a large conical flask. Then we place a stopper and we shake the flask at interval and release any pressure after each shaking. Like if any gas is formed, so to allow that gas to escape, we open the flask. Then separate 2-chloro-2-methyl propane from aqueous solution using, why? Because hydrochloric acid is there, so that will be aqueous. So we want to separate it. So separate using a separating funnel. So we use a separating funnel and separate these two layers. Then 2-chloro-2-methyl propane is separate in the separating funnel. We add 20 cm³ of sodium hydrogen carbonate. So the purpose of sodium hydrogen carbonate is to remove any trace of acid. If any acid is present, this will remove. The sodium hydrogen carbonate will remove that acid. And then we shake the separating funnel so that we release the pressure build up due to carbon dioxide. Then separate 2-chloro-2-methyl propane and repeat the washing with sodium hydrogen until this washing step is no longer necessary. So how we will make sure that this washing step is no longer necessary? Once, because if carbonate is not forming reacting with acid, so there will be no more bubbles formation. So once the bubbles are not forming in the mixture, it means all of the acid is being neutralized by carbonate. Then we transfer 2-chloro-2-methyl into a small conical flask. We add suitable drying agent. So drying agent is to remove any trace of water. So we can use sodium sulfate or calcium or silica gel or calcium sulfate. Then filter off the drying agent. Drying agent should be solid. So and we filter it off that drying agent. Then collect 2-chloro-2-methyl propane into a distillation flask. So we use a distillation flask, and then we heat the flask, the fraction distill off from 50 to 52. So the data is given, the densities of each is given, the molar mass is given, and the boiling temperatures are also given. Like first thing we were having alcohol, and then we convert this alcohol into 2-chloro-2-methyl propane. So the first part, calculate the volume of 2-methyl propanol used in the preparation. So in the beginning, as they mentioned, we know the moles. Here they mentioned 0.2 moles. So if we have the moles using and we have the density, the molar mass is also given. So using the moles, we'll find the mass in gram, and using a density and the mass in gram or mass, we can find the volume which is used. So moles are 0.2 multiplied by molar mass to get mass in gram. So 0.2, because the formula moles equal mass in gram divided by molar mass. So moles are 0.2, molar mass is given 74, and mass in gram we don't know. We cross multiply, so 0.2 multiplied by 74, 0.2 times 74, that's equal to 14.8. So 14.8 gram is there, that is the mass. But in the question we need the volume, and we have the density. So density is mass over volume. The density of the solution was given 0.789, and the mass is 14.8, and volume we don't know. So the volume will be 14.8 divided by 0.789. So because the unit of the density is gram per centimeter cube, so when we simplify, we'll get in gram per centimeter cube. So centimeter cube will be the final answer. So 18.76 centimeter cube. So that's the volume of the solution which is used for this experiment. The next part, draw a diagram of separating funnel that could be used in step 3 and label 2-chloro 2-methyl propane. And so the position in the separating funnel depends on the density of the two substance. So here you can see the density of 2-chloro 2-methyl propane is 0.8, which is higher than density of the 2-methyl propane 2-ol. So it means the high density liquid will be there at the bottom. So a separating funnel with the tap, and we will label the two layers will be there. One will be the aqueous, and in step 3 we have, because in a separating funnel what we are doing, we are separating the aqueous layer from the organic layer. And now we don't have the reactant, we don't have alcohol, so there is aqueous layer. Aqueous layer means water is there. And what is the density of the water? Density of the water is 1 gram per centimeter cube. And compared to that 2-chloro 2-methyl propane, that density is 0.8 gram per centimeter cube. So compared to aqueous, because now in the separating funnel we don't have the original reagent, we don't have alcohol, we have aqueous layer and the organic layer, which is 2-chloro 2-methyl propane. So in compared to that, what will be the position? So the position, because it's having a low density, so the 2-chloro 2-methyl propane will be there as the upper layer and aqueous layer will be there at the bottom. So in the beginning, when I mentioned that the 2-chloro 2-methyl propane will be there at the bottom, was with reference to the two mixtures, two substances, but with reference to the water, because or aqueous layer density of aqueous layer is 1 gram per centimeter cube, so that will be there at the bottom. The next suggests why the product is washed with sodium hydrogen carbonate in step 4. So what is the reason for washing any substance with sodium hydrogen carbonate solution? Is to neutralize the acid or to remove acid. So the purpose is to neutralize or to remove acid. Then how would you know that no more further washing is needed? How we make sure, or how we identify that we don't have to add now sodium hydrogen carbonate? So until no more bubbles are seen, so no more bubbles or pressure buildup. So once there are no more bubbles formed, we can identify that we don't have to add sodium hydrogen carbonate solution. Suggest a suitable drying agent So the common drying agents which we use in the lab, we can mention anhydrous sodium sulfate or anhydrous calcium chloride or magnesium sulfate. But better use the term anhydrous because these hydrated compounds are not drying agent. Anhydrous compounds are drying agent. So here we can mention anhydrous sodium sulfate. Then draw a label diagram of apparatus you would use to carry out the final distillation. And it's of 4 marks. So you have to practice these. You must be able to draw these apparatus. So we have to draw the distillation apparatus. So first, and we'll have a round bottom flask will be there. Then we'll place a thermometer, and then the condenser will be there. Water inlet and outlet. You will also label. So the round bottom flask. Then a Liebig condenser. Here it's closed from the top, and the thermometer is placed to identify the temperature of the vapors. Then in this Liebig condenser, you have to label the water inlet and outlet. So water enter from here and leave. It should be correctly labeled, and then we collect, distillate in the other flask. And the heat source will be there, like a burner, Bunsen burner. Then the next part, a reaction produce 18.7 cm cube of 2-chloro-2-methyl propane starting from 0.2. 2-methyl propane to all, calculate the percentage yield. So practically it is producing 18.7 cm cube from zero point 0.2 moles of 2-methyl propane to all. Calculate the percentage yield. So first, because the percentage yield is a practical value, like practically how much we are getting a product divided by theoretical value into 100. So using this, we can work out the percentage yield. So zero point 0.2, that is the total number of the moles of the reactant we are using. So using the volume of a product and the density, we'll find how much mass of a product is produced. And from mass of a product divided by its molar mass, we'll get the moles which are produced. Theoretically, zero point 0.2 should be there because the ratio between 2-methyl propane to all and 2-chloro 2-methyl propane, the ratio, the first in the beginning of the question it is given. So ratio between them is 1:1. So if 0.2 is there, if 0.2 mole of 2-methyl propane to all, so theoretically we should get 0.2. That is a theoretical value. But practically how many moles we are getting, so how to work out, this is a volume and we have the density that is also given in the beginning of the question. So using the volume and density, we'll find the mass. Density is mass divided by volume. So mass is density times volume. The density is 0.842 times the volume is 18.7. So we'll get the mass in gram, which is 0.17. Uh, this is not the mass in gram. This is a like the 0.824 times 18.7, so 18.7 times 0.842, that is 15.7. 15.7 is a mass in gram. Then we need the moles, so moles equal mass in gram, which is 15.74, divided by molar mass, that is also given in the question, 92.6. So this will give us 0.17. So theoretically, practically we are getting 0.17 mole, theoretically we should get zero point 0.2. So percentage yield is equals to 0.17 divided by zero point 0.2 multiplied by 100. So this will give us about 85% yield. So the product is about 85%. So that is the percentage yield of this reaction. So percentage yield is a practical value divided by theoretical into 100. Either if moles are given, you can use the moles. If volume is given, we can use the volume. Or mass is given, we can also use the mass. Then a suitable chemical test for chlorine in chloroalkane. So how we can test the presence of halide ion? We can add silver nitrate, acidified silver nitrate. As a result, it will give white PPT if chloride is there. It will give cream color precipitate if bromide, and it will give yellow PPT if iodide is there. Suggest then suitable chemical test is there. 2-chloro-2-methyl propane is added to chloroalkane to a mixture of aqueous silver nitrate and ethanol. So why ethanol is added to a mixture? What is the purpose of ethanol? Because these halogen alkanes are insoluble in water, does not dissolve in water. So if we directly add aqueous silver nitrate or acidified silver nitrate, the two substances will never mix with each other. So these halogen alkanes are insoluble in water. So if we add aqueous silver nitrate directly to this, it won't make any observation, like we don't observe. So that's why what we have to do first, we have to dissolve in ethanol, because in alcohol and aqua water can mix with each other, or aqueous and alcohol can mix, and that's why, so why ethanol is used. So it is used to dissolve halogen alkane so that the two reagents can mix with each other. Then give the expected result for this. So whenever halogen alkane or like chloride ion is there and we add silver nitrate, so silver chloride will be formed. And what is the observation of silver chloride? That is white precipitate or white PPT. So you have to learn these observations according to the question.